Let us continue our explorations. We are in Calculus 2.1, and we're dealing with this idea of what is calculus? So what is this study? On the most basic level, every calculus problem involves a limit. And what is a limit? So that's a big part of what we're going to be studying in the beginning. As we continue, we're going to use that idea of a limit, and we're going to find the derivative. And what is the derivative? So, first major concept in calculus, and then the second major concept in calculus. The derivative is going to be the instantaneous rate of change, where we before could only calculate the slope between 2 points. Now, we're going to calculate the slope at a specific instant in time. And so this will call the tangent line to a curve, and the tangent line to a curve is the derivative. After this, the third major concept that we'll consider is finding area under curves. Before, we could do it with these simple geometric shapes like a rectangle, a circle, parallelogram, things of this nature. Now we have curves, and we can find the area exactly underneath those curves. And so this is called an integral. And the order that we will flow through the course is first First comes limits, then comes derivatives, and then integrals, and then some more for our BC friends here. Okay. I really love this. It by and large shows what we're going to be doing with this idea of a derivative and this idea of a limit working together. So we have some distance between our 2 points along the x-axis, and they call that the delta x, or the change in x, some finite value. So I'm going from this x to this x, and that is called delta x. So if you have a beginning point, c, well, then you could have another point, c plus delta x. And what we're going to see is we want to shrink that delta x. Here, the delta x at q was way out here, but then we shrunk it a little bit, and then we shrunk it some more, so it was getting closer to some value. And in this case, maybe they're going to call that c. So the limit is when this second point, or this delta x, goes to 0. So the limit as delta x goes to 0. And so we'll practice limit notation. Moving forward, we have an exploration to consider. I'd like you to do this in your notebook. Consider the region bounded by the graphs of x squared, y equals 0, and x equals 1, as shown in part A of the figure. The area of the region can be approximated by 2 sets of rectangles. One set inscribed within the region and the other set circumscribed over the region, as shown in part B and C respectively. Find the sum of the areas of each set of rectangles, then use your results to approximate the area of the region. So we want to consider how many little rectangular regions might we have here. We go from here to here. That's 1, 2, 3, 4, 5. So is that 0.2 across? This is 1, 2, 3, 4, 5 rectangles. So yeah, if we go 1 divided by 5 is going to give us 0.2. So our rectangles are going to have widths of 0.2 units. The heights are going to be something different. So let's pause and let's consider that now. And that distance across is 0.2.